Good afternoon, everyone. All right, so without further ado, let's go ahead and get started. If you'd like to introduce yourselves, that's totally fine too. You're welcome to unmute yourself at any moment and ask me questions, right? Really, I don't like to do monologue. I really love to interact with my students all the time. And here it starts. So this is going to be AP Physics C Mechanics Virtual Open House. Once again, good afternoon. The course is AP Physics C Mechanics. It's not E&M, just mechanics, the first part. Of course, in the future, we can also have E&M version of it, which is the second exam. And by far, these two exams, AP Physics 1, AP Physics C Mechanics and E&M is considered to be one of the or two most difficult tests by College Board. So the course we're talking about is going to be online through Canvas. We're going to have our Canvas course page in which once you sign up, you'll be registered automatically into the Canvas. And then probably most of you already aware of what Canvas is and how it really functions. So it's going to be a digital classroom in which the homework assignment will be posted and the class material will be posted, all of those kind of things. And of course, you'll be able to interact with your instructor. So sessions are going to be live through Zoom, like we're doing now today. And the dates for this specific course is going to be from July 30th to November 12th, all on Sundays between 1 and 3 p.m. Central Time. I am located in Virginia, so Virginia time is going to be 2 p.m., which is Eastern time. Those who are connecting and joining us from California, your time is going to be 11 a.m. Pacific time. And if anyone is really connecting from other time zones, you know how to find the time for your particular zone. So there'll be no class on September 3rd. So the total number of classes will be 15. Depending on the demand, maybe we can actually add maybe 1 or 2. I'm not sure about that. I'm free of any obligation or charge, basically, to kind of maybe review if needed towards the end of the session. Sessions are going to be 2 hours long. And what I really like to do is to interact with my students, to get together and solve problems. But first and foremost, obviously, is going to be covering the materials we're going to cover. So a little bit about me. Oops, not that one. A little bit about me. My name is Islam Bedir. My students call me Dr. Bedir. I did my studies in all physics, bachelor's degree in physics, master's degree in theoretical physics, and then PhD degree in also theoretical physics, theoretical nuclear physics that I'm really, and I have been teaching physics and related subjects for more than 10 years now. Physics and labs and all these university physics courses. So as a young boy, I also participated in really numerous many contests, Olympiads, physics Olympiads, which I'm really have a very high esteem and high regard to those years. And I really consider them really precious. Back then, it was considered to be most prestigious really contest, and I think today too. And if you are interested in those, I would really recommend that you go and follow your passion in that regard. So I attended national and also international physics Olympiads, but I'm currently teaching computational physics. Computational physics is basically a combination of university physics and computer programming in Python. So we are, with students learn pure universal physics in one hand, and then we also learn how to program on the other hand, and then down the road we just merge the two fields. So this is what computational physics is. So then given a problem in physics, you're able to solve it using, let's say, C++, Java, Python, any language of your choice. So that is the course I'm teaching at the institution, but this is different. So here we're going to be covering AP Physics C. I had students whom I studied with for AP Physics 1, AP Physics 2. These are algebra-based physics, but also AP Physics C. So AP Physics C is no different than AP Physics 1, I would argue, except that there's a little bit of calculus element in it. And of course, a little bit more rigorous compared to AP Physics 1 and 2. But it's really beautiful test, beautiful exam that I'm going to focus a bit. But before going there, I'd like to really lay out my approach. The way I see all of these exams, AP exams, or contests or Olympiads, is just like a race, like a competition, not another burden in front of you achieving some kind of a high goal, but rather a kind of a real amusement. It's sort of really sitting at your home and doing all this 24/7 something, playing with games and all that. Instead of doing all of this boring stuff, maybe there's another really engaging, fun stuff, a fun activity, and that will be these contests. So I would call AP Physics C as a beautiful contest. But in our setting, of course, it's not just a contest that we compete individually, but it's going to be teamwork, team effort. So anyone who is joining this classes, I'm going to consider as a family who going to support each other, right, in achieving the highest goal. And highest goal in this contest is going to be no less than 100% on AP Physics C. Really, it's 5 out of 5. So 100% and no less is our expectation from this class. And the way we're going to approach the problems is obviously first we're going to cover the content, right? Whatever the content of that week is. And then we're going to dive into, after understanding the content and dive into and solving different problems related to that specific area. But first and foremost, of course, we have to do our part. Physics is by no means it's easy field, right? It's easy subject at all, not at all. But once you start learning its language, you see that it is the most favorite. It is the most likable and joyful subject one can learn in his or her lifetime. That's basically it. And as a homework, we're going to really set, let's say, the assigned chapter for this week is going to be, let's say, momentum. Then everyone is going to really study momentum that week. And then when we get together, we're going to quickly review, go over questions and things that you stumbled upon or, stuck and couldn't understand conceptually. So we're going to review concepts first. And then to reinforce the concepts, we're going to solve problems. And then we're going to solve all these most difficult problems within that subject. So there are tons of textbooks you can choose from. And two great choices of textbooks will be, one, it's called Fundamentals of Physics by Halliday, Resnick, and then Walker. Another one is by Young and Friedman. It's called University of Physics. Both of them are excellent books. And I had a real hard time choosing between these two, which one will be best, for AP Physics C. I mean, after all, given both have really great animations, pictures and illustrations and tons of examples and all of that. But I find the one on the right side, which is the University of Physics by Young and Friedman, to be much more organized and also up to date compared to the previous one. Although both of them are recent editions, I find this particular title to be more cohesive and organized and tailored for students' understanding. Both, of course, provide end of chapter review, end of chapter summary, but I kind of lean towards this particular title, University of Physics by Young and Friedman. So I think it's an excellent choice that you can definitely buy from Amazon or any other place of your choice, hard copy or paperback edition. Today I checked, the paperback edition is about, maybe you can find a new one for about $50. Hard copy is always expensive. Maybe it's around $200 or maybe less. You can always find and purchase e-text of the book if you're comfortable reading from a digital device. I personally like really hard copy of a book so that you can, turn around the pages, highlight, to all of those kind of things. And, it's always really great. One advantage of this book over others is that this book also provides difficulty level of problems at the end. End of the chapter problems, they also sorted out or indicated the difficulty level with dots. For example, if you have one dot, that means it's okay, it's difficult, yes, but you have 2 dots, that means it's a little bit more difficult. 3 dots or 4 dots means that they are challenging problems. But it doesn't really matter. Once you understand the concept, there's really no challenging problem. all of them will be just amusing problems, amusing, things to just do, dive into and spend your time lovingly. So I think I'm going to decide on this book as our textbook, and the chapters are going to be assigned through this textbook. End of the problem is also going to be related and assigned through this textbook. So if you're joining, and I would highly recommend that you acquire this book. Maybe you can check out from your library. Best to purchase, of course, if you can afford it. So that is the textbook. Those who are passionate about physics, and really I call them physics fans, then there is this title called Physics, Not Fundamentals of Physics, Just Physics by Holliday, Resnick, and Crane, these three authors. It's a little bit dated. It's I think last published in 1992 or so. So volume 1, there's a volume 2 book. What I really like about this textbook, which is out of print anyway, and you can buy a used one for about under $7 or so, maybe from eBay. What I like about this particular book is that whenever it really covers the classical physics, let's say it's a momentum, let's say it's energy, let's say it's rotational motion, or whatever the case is, or simply linear motion, right? Towards the end, it also mentions the limitation of that particular approach. After all, there's a classical physics, and we all know that the classical physics is limited, and there's what we call modern physics. And in modern physics, we have a better version of physics. What I mean by that is that the classical physics has its own limitations. Let's say, and the limit is the lower speed, right? And when you go to higher speeds, then the whole classical physics kind of breaks down, and then you can't apply it anymore, and you have to switch over to relativistic mechanics, which we call basically a part of modern physics. So what's really great about this title, it actually mentions it towards the end of that particular chapter, is that, hey, we covered thus far, it's all good, but you should know that, here are the limits for this particular approach. And when you go about this, and then here how you have to approach. So kind of an awesome approach. And I don't really know why they didn't really continue it. So they definitely discontinued this approach, which I feel like it's a disappointment. But anyone who's interested, they can also have this book as an alternative to read besides our main textbook, which is this book. All right, so there will be also prep books out there. I'm aware of all of these, prep books and, their content. For example, Princeton Reviewed and Barron's AP, and then there's another book. And of course, there's a College Board. And the College Board book is actually not a book. It's online problems from their official website. It's and they have number of different problems. So basically, the College Board and all this rest of the prep books. What I'm planning to do, of course, you don't really have to get all of these books at all. Part of this course is that integrating all this wonderful content found in these prep books, as well as in the textbook, in order to be able to solve problems by College Board. After all, AP Physics is done by College Board, so our really main task is to be able to solve the problems or test sometime in May that you're going to be taking. That's going to be AP Physics C. So I'm going to infuse and integrate all of them, pull out the relevant, questions and problems from these resources, and then provide them as we go along, and so that you are kind of in that level, you'll be able to solve problems related to AP Physics C mechanics. So any questions thus far? I don't see a chat box in front of me, but I'll say if you can unmute yourself. Oh, maybe there is. Just give me 1 second. You can see something. Right, let me put it that way. All right. So if you have any questions, you can also chime in the chat box and then see what you have. So there's a question that I'm going to really address it before moving forward. How many problems do you assign each week from the University of Physics books? That's an interesting one. I haven't really given a deep thought about this. I'm working with a student a very passionate student, for example. We cover a chapter from the textbook, and the way really we're working with him, for example, right, is that he solves all exercises and all problems at the end of the chapter, all of them, and then he just sends me the ones he is not able to solve. So I find that kind of a fascinating way of doing it. But of course, I'm not going to assign such a heavy burden on your shoulders, but instead there will be maybe 15, maybe 20 problems that you will be given to solve weekly, around 20. So number one, it is going to be cover chapter, right? Read chapter, or perhaps better term will be study the chapter, maybe once or twice, right? Underline all these really great concepts, and then work out the problems within the chapter, right? There are worked out problems that you're going to see, plenty of them, in fact. And then towards the end of the chapters, I'll assign about 20, maybe 25, but 20 problems that you will be just posting in Canvas. That's all right if you can't fully solve any of them, which is totally fine. And the meetings are going to be really address those, problems that you couldn't solve and still confused about. So it's going to be just ongoing process. So you can always reach out to me if you have any questions and confusion and problem or something like that. So my task, the way I see it, is that to provide you all the support you need, and the best and that I can, actually, of course. And so I'll make sure that you're able to reach out to me by means of email, Canvas, maybe live Zoom sessions, and or any other means that you find comfortable and working best for you. So let me move forward. The content of the course, as amended and changed recently by College Board, is that now they're asking from 7 chapters. So your task is to learn and master all these 7 units. And so this is going to be just that. In the past, they had different units involved in it, but for AP Physics C Mechanics, all you need to do is basically to study and excel at these 7 awesome chapters. No, you do not have to pass Physics 1. There is a question, one of the students is asking, do I have to pass Physics 1 to take this course? I don't think so. This particular course offered by Momentum Learning doesn't have any prerequisite, to my knowledge, to my understanding. So yeah, you can definitely take this course and you can take exam and then just pass exam. So our idea is that if you are taking any calculus-based physics, scratch that. If you're taking calculus, or not even taking calculus, but you know how integrals work, how derivatives work, then you definitely can take this course, ace at it, and then simply pass AP Physics C Mechanics. Now, since there are 7 units, 7 chapters that we need to master, we need to pass. So the way I propose is that we allocate 2 weeks for each unit. So for example, when we start unit 1, everyone is going to be assigned to study that chapter, unit 1. And then after that, we're going to get together, we're going to really review concepts and all that, make sure that everyone really knows on the same page, and then we're going to solve a number of problems. And then next week, we're going to excel at it by solving challenging problems. So it's going to be 2 weeks per unit. And in total, we'll have 14 weeks to go like that. And then the last, which is session number 15, we're going to allocate for purely review, perhaps cumulative, like all of these 7 chapters combined. All right, so there are a few other questions in the chat box. Is the depth of the course enough for taking AP Physics C? Julia, this course is AP Physics C. Yes, it's AP Physics C Mechanics. So if you are interested in taking AP Physics 1 and 2, which are algebra based, this is going to be plenty. Yes, this is going to cover those as well. So anyone who is taking the course, I think they'll be definitely eligible to take AP Physics 1, not AP Physics 2, because we don't really cover electricity in this course, but they can take AP Physics 1 algebra based. They can also take AP Physics C mechanics. So in the future, if we are going to do some kind of AP Physics C, E, and M, then definitely then you can take AP Physics 2 algebra based, and you can also take AP Physics C, E, and M, right? So consider this as the highest level physics course available out there, right? Higher course than this one is going to be FNET. FNET is basically the National Physics Olympiad that some of you may be aware or know about. And then after that, students are going to FNET, they'll go to International Physics Olympiad, but that's a totally different story. So there's another question by a student whose name is SM, I would say. How much more time efforts does it take to learn AP Physics C-M, I think meaning mechanics, than AP Physics 1 if one has already finished AP Physics 1? Thanks. So since you finished AP Physics 1, I think that it will be fairly easy for you, definitely, because now you're actually familiar with the concepts. So that means all you need to do now, you need to readjust with the approach to the problems, because now you're going to have some more than algebra. There will be calculus. There will be problems that I'm going to show in a bit, how they are slightly different regular problems. But yeah, it's going to be fairly easy. I can't really tell exactly how long it's probably going to take. It depends on the person, obviously. But if we were to take this course, then definitely towards the end, I will feel that you'll be ready. Another question, after this course, will you continue to teach AP Physics C, electricity, and magnetism? I would love to. That's my passion. I would love to. But I'm not the admin for Momentum Learning. If they offer me to give this course, I would love to. And definitely it will be much more convenient to continue with the same set of students to do AP Physics C, E, and M, yes. But currently, I don't know if they're going to offer that course. Another question by Julia: for someone already took AP Physics 1 and almost qualified for USA Physics Olympiad, is this the right course? Yes, of course. There's no higher course than this one. So this is the highest course, AP Physics C Mechanics. If you already qualify for a USA Physics Olympiad, then that means this is going to be a piece of cake that you're definitely going to enjoy. And yes, there will be problems, and probably it's going to be very easy for you, because now you have that you have already covered those chapters. You'll be more or less doing problem solving, and then providing those solutions, and then being challenged with different set of calculus-based physics problems. Yes, and I'm really glad that some of the students are really rigorous and qualify for USA Physics Olympiads. Wow, that's amazing. So, section, probably you already know AP Physics C as AP Physics 1. They have two sections. Section 1 is about multiple choice problems. So you have about 35 questions, 45 minutes, and it constitutes about 50% of the total exam. And there is also same time, but only 3 questions, what we call free response. Now, free response questions are not that difficult at all if you know how to approach these problems. If you know concept, then these problems are much more actually lovable. They're very amusing problems, and you just sit, lay back, and relax, and enjoy doing these problems, free response questions. So, so this is basically how AP Physics is as per recent development, and that's going to be just that. And then now, if we were to look at a few problems before looking at this, I think there's a question that I need to address quickly. Sandeep is asking, could you kindly go back to the slide that had the ISBN number for the University of Physics textbook? Yes, of course. Let me go ahead and provide this. So this is going to be our textbook. It's really neat and organized textbook with tons of illustrations, tons of pictures, tons of really great. And one of the things that I really mention about this book is that when the formulas are derived and really given to you, those formulas are also annotated. That if you want to quick look at those formulas and try to really understand what they're for, this is really great approach. They just annotated those formulas in gray. What's great about this book, Fundamentals of Physics, is that, and especially this book, is that the formulas are derived. So you're given all these questions and problems derived. So these are that. Just give me 1 second. I think it's my daughter. Canım. Kuzum gel. Ama ben şimdi dersteyim. Gel. Dersteyim oğlum. Dersten sonra gelmek ister misin? So, and so we're together now with my daughter. All right, so that's that. Yes, if you qualify for USA Physics Olympiad, then this is indispensable textbook for you. You have to get this book and you have to start reading this textbook. So that's that. All right, let's move on. Sunday, were you able to actually get that ISBN number? Sorry, there was a distraction. Okay, perfect. All right, what else? That's that. Now, if you were to look at this problem, right? Unlike AP Physics 1, you're probably going to get asked this kind of question, which is, as you know, maybe some of you already taking calculus had this kind of examples, like here, given what? Given problem in which what we have? We'll have velocity, right? And the question is to find acceleration. So how do we do this problem? Anyone would like to suggest, you can always do so. But of course here, it's really, anyone who's taking calculus, you would know that in order to go from velocity to instantaneous acceleration, all you have to do, you have to take the derivative. And the reason for that is because as per definition of acceleration, the way we define acceleration is what? Acceleration was defined as rate change of velocity, meaning that delta v, right, over delta t. That's kind of a calculus terminology for expressing the rate change of velocity. And of course, when we take this one, but before I take this derivative, first couple of things I would like to mention here is that velocity is given, yes, but what is that 60? What is that 0.5? It seems like there are things missing here. And the reason I did that is just to show you that when you have something like that, so that means this 60 comes about its unit, meters per second. And then 0.5 comes about its own unit as well, which is, as you see, meters per second cube. Right, and the reason I did cube there is because when you have t as a time in seconds, right, it's going to cancel with that cube and give you 1 over t, 1 over second. And overall mass over second gives you the right unit for velocity. So what I did is basically in a nutshell known as a dimensional analysis, which is a very powerful tool to get by and solve problems in physics. So it's called dimensional analysis. So when you take a derivative, back to problem, when you take a derivative of this particular given equation, then it's going to be, when you have a constant becomes 0, as you already know, and then 0.5, and then you have derivative of, let me put it there, of t is going to be what? It's going to be right? As you remember, when you have a function to the power of n, then n will comes out and then it gets n minus 1. So in other words, 0.5 is going to be multiplied by 2, and then all you left is just t. So what happened here is that t, right, that 2 is diminished by 1, and that 2 is right there. That's basically the derivative, right, of any given function. So this is acceleration, time-based acceleration. So what do we do with that? Whatever the follow-up question is. So what we found is that time-based acceleration, instantaneous acceleration, is what? None other than basically t. And the unit here is obviously, so what is the unit? We know that the unit of acceleration is meter per second squared. And here the unit will be of the whole thing is going to be meter per second cubed, so that when time is added, it gives you the right acceleration. Let's say when time equals to 1 second. When time equals to 1 second, then the acceleration is going to be 1 times 1. It's going to be 1 meters per second squared, and we're done. So, is this problem difficult? Not at all, but it will involve some calculus in it, as you can see. So, what about this problem? Very similar, but again requires some calculus. So here we have Sam driving his car along a straight line, straight way. At t equals to 0 seconds, when he is moving at 10 meters per second in the positive x direction, he passes a signpost at x equals to 50 meters. His acceleration as a function of time is given by that equation. Question is, find his velocity and position as a function of time. Okay, that's going to be question number 1. Then question number 2, when is his velocity greatest? What is that maximum velocity? And where is the car when it reaches the maximum velocity? Right? So these are some of the problems. I just picked up random 2 or 3 problems and just wanted to show that they're not extremely difficult problems at all, but they do require some calculus. So if you never took calculus course before, it's all right. You can quickly pick up any review, quick guide on what calculus is, or and then you can just definitely get an idea how things will work. So it's basically calculating the area. For example, when talking about the integral, right? Integral is what? Integral is finding the area of something like that. You know that, for example, in order to find the area of this triangle, right? It's basically height times base divided by 2. But what if the area that you're trying to find is not like regular like that, but instead it is something like curving like this? How do you find the area of this surface? That's where the integrals will come along, right? And that will become very handy. Is that what you do is you just divide all the segments into pieces and you start really summing all these pieces up in an attempt to calculate the entire area. That's what we like calculus. That's what the integration basically is about. So, like I said, you can definitely learn quickly how things will work, and that is going to be very helpful if you haven't really taken calculus at all. So, coming to this question. So, question: how do you solve this problem? Given acceleration, how do you find velocity and how do you find position as a function of time when acceleration is given? Right? So now you know that it's reverse of derivative, meaning that it's going to be integration. And the way we know it is because, remember how we defined acceleration? Acceleration was defined as rate change of time. But then what it implies is that a times delta t, right? So if you now take integral of both sides, you're going to really find the velocity, right? Final velocity minus initial velocity, obviously, and then you're going to have acceleration times delta t. I'm quickly going over, so if you're not really familiar with what integrals are, that's all right. We'll just quickly reviewing these problems to set kind of a tone of the style of the problems we're going to be dealing with. So that means velocity final that you like to find, it basically depends on the initial velocity, but also it depends on the acceleration, right? Now, because this acceleration is uneven, meaning that it's just not a constant, then you have to integrate that. It's basically kind of a curvy, function in which you want to find the area under that curve. So going back again, so what was the function? 2 minus 0.1. So we need to have initial velocity plus, so we have 2 0.1 t, and then we'll have delta t. Made a mistake, just give me 1 second. So t, delta t. And then from where to where? It's going to be from 0 to whatever the time we want to calculate that. Okay. So now initial velocity, what do we get that initial velocity? Well, initial velocity, it's actually provided in the question. The initial velocity says that 10 meters per second. And the initial time was starting from 0 seconds. So it's going to be just that. We're going to say that here we have initial velocity, which is 10 meters per second. And then we'll have 2. When you take a constant and its integration is going to be just 2t, and then minus 0.1, and then t. T is going to be raised to power of 2, and then divided by number 2. Okay, so once again, this is just the integration. No worries if you're kind of a loss at this point and you have no idea what's going on. That's all right. We're going to review these as well. And we're done, really. And in order to find what? In order to find position versus time, right? Or position function of this particular motion, what is it you need to do? You need to just continue the same trend, meaning that velocity is simply defined as the rate change of position. Well, that means in order to find, I'm just skipping some steps, in order to find a final position, all you have to do, you need to just simply integrate velocity, right? So initial position, it was really saying that it's 50 meters. So you're going to really get that 50 meters there. And then finally, we're going to really borrow this equation and plug it in there. I'm going to skip units. 10 plus 2t minus 0.1 over 2t, right? Delta t. From where to where? From 0 to t, any choice t. And it's going to really provide us what we, looking for. And that is 50 plus 10t plus t squared minus 0.1 t to the power of 3 divided by 6, and so on and so forth, right? I'm not really going to continue, but I think you get the idea. Another problem, like look at this problem. So in this problem, what we have is that we have two blocks on each other, and there is coefficient of kinetic friction for all surfaces is given as mu. So what is the resulting acceleration of the lower block? So it's really talking about this lower block. If a force F is applied to the rope, assume that F is sufficiently large so that the top block slips on the lower block. So how do we solve this problem? Now, this problem is in unit where we cover dynamics, Newtonian laws and motion. So in which what we do is we simply come up with the free body diagram. Free body diagram for the first block, free body diagram for the second block. What it means is that we're going to really illustrate objects separate from one another and going to just draw all forces acting on them. That's what's called free body diagram. If you were to free an object from everything else, what forces acting on it, like external forces, that's basically it. So if you look at this, the first object is really acting upon it, weight force, for example, we're going to call it M1G. And then there's normal force on it. Let's call it N1. What else? Now, because it is moving in what direction? Because it's really moving, there's friction and nothing else that really pulls it this way, right? So it's going to be that friction force, let's call it friction F, which is related to mu times N1. Okay, that's basically no other forces acting upon it. And of course, here we ignore air resistance and whatnot. Then the free body diagram for the second object is going to be obviously external force F. What else? Will have its own weight force, which is M2G, but also weight force by the first object on top of the second one, which is going to be N1, right? N1, which we know that has to be equal to M1G. What else? Then we have a friction force exerted on this one, which equals to the friction force exerted on the first block, mu times N2. And of course, N2, it's hard to draw here, but it's going to be weight force, normal force exerted on, normal force exerted on block 2 by the surface. So we're going to call it N2. So all in all, this is it. All you need to now do is basically combine it all and find things related to it. So acceleration of the lower block then is going to be none other than, let's find it out really fast. It's going to be F minus friction force, which is mu times N2, okay? So that's that. And then, of course, there's one more friction force that we shouldn't really forget is the friction force right there occurring in that surface, which is going to be opposing force. We need to also indicate that, opposing force. So, and finally, if we were to add that as well, it's going to be, so this is that I mentioned, and mu times N1G, that equals to M2A, and we're done. That's basically it. From here, you see that the answer should be choice A in this particular problem. So again, this session is just basically a live session for the open house and wanted to provide you ample problems related to AP Physics C and how to kind of we get by solving those problems. So now let me go ahead and open floor for any questions you have. Please go ahead, do not hesitate. If you want to unmute yourselves, absolutely fine. I would love to hear your voice. If not, you can use chat box to ask me questions. Going to wait a bit. Is there a laboratory requirement? One of the questions Sandeep is asking, is there a laboratory requirement? There is no lab requirement for this course at all. I remember this course is not AP audited course. And so there will be no lab, but I would love, because it's AP Physics C and it's a preparation for that exam, I'm going to provide the elements needed from lab experience. So I'm going to really say that, well, here, when you're trying to, the question in the free response is that set a lab in which this should happen. And right there, we're going to really discuss how things will happen in real life. Perhaps I'm going to provide you with animations, with things like that, that will give you some elements of lab experience, and so that you can definitely relate to AP Physics C. But no, lab is not really required. Right? Any other questions? All right, with this one, it's been a pleasure for me to meet you, some of your names, see some of your names in this Zoom session. And so once again, my name is Dr. Bidir, and I'm super excited to teach this course. So through Canvas, through Zoom, and I'll be available for you to reach out to me. And if you have any questions, you know what to do. Wishing you a beautiful day. Thank you, and have a great rest of your summer. Bye. Yes, if you have still questions, you may remain and ask me questions like that. So one of the questions Benjamin asked is that, no, actually, Benjamin, in this particular question, all surfaces had friction force, meaning that all surfaces are, they have friction, so you need to consider friction in all four surfaces. Juliet, the difference between two holiday titles, it's an excellent question for which it took me some time to really figure this one out. But the difference between those two titles is that around 1992, right? They around 90 is that what they did is that Holiday and Resnick, they invited another professor. His name is Crane, and he's a professor of modern physics. So he was on board to provide those kind of towards end of chapter limitation things related to modern physics. So he was really instrumental in providing the modern physics component to the entire awesome text. But then I don't know what happened after 1992. So out of sudden they released the 5th edition, right, of that line. But then that's it, they stopped it. Then we see that another author comes in whose name is Walker, last name is Walker, and then the title changes to Fundamentals of Physics from Physics. So, and Crane is disappeared. So it's just Resnick, Holiday, and Walker instead of Resnick, Holiday, and Crane. But there is also a huge difference in the treatment of the subject too. All those wonderful things that I mentioned about the modern physics included towards the end of every classical physics subject, they're all removed. They put all the way to the end towards modern physics. So that component is completely lost, that I find extremely disappointing. And also approaches to problems also is a little bit different. But most important to what really misses in the new title is that end of the chapter, very challenging problems are completely gone. So in 4th edition, also 5th edition of physics book by Resnick, Holiday, and Crane, you can still see those very challenging problems, but not anymore in the modern in the new editions, which is called Fundamentals of Physics. You don't see those challenging problems anymore. So there are more problems, yes, but all of them are kind of doable, easy problems, and you can just solve them all, and you're fine. But not tremendously difficult problems. They're not there anymore. If that makes sense to you. Another question is that, will you discuss the labs, specific result of the labs covered in the exam? Yeah, absolutely. So remember, in the exam, there's really no labs, right? It just simply free response questions are worded, are construed in a way that really tells you to go ahead and set up a lab in which you have a block, you have a pulley, you have this and that, which is basically solving another physics problem in an amusing way. But of course, it involves a little bit of a data analysis in which I'm going to definitely provide. As we solve those problems, those elements will be provided, will be given, and then you're going to see that they're just not any different than any regular physics problems. So yes, to answer your question, yes. So Julia, I think I'm planning to assign reading from one textbook, not multiple. For, as you already know, like I don't really want to bore you with a lot of materials at all, but it's going to be just one textbook. But as for the title that I mentioned about the Resnick and Holiday, the 4th edition textbook, it's going to be a fun read, definitely. If you're into physics and you're passionate about physics, then I would highly recommend you get it from eBay. Trust me, it's a lot less than $6. You can find a used book. And then when you read those chapters, you feel like, wow, this is completely different. There's this mystery about these chapters, the way they've been written. And no wonder why those books were stellar at the time, but unfortunately they discontinued it. So when I came across this title, like Resnick, I remembered it because we also studied it when I was an undergraduate student. And so definitely, if you want to study that title as well, definitely go ahead. It will add tremendously to your knowledge. So another question by Sandeep is that, what do you recommend reading from University Physics to be ready for the first class? I'll be assigning right away before the first class will be chapter 1 or chapter 2, maybe both chapters, in which all these materials are very familiar. It's about the units and significant figures and motion, definition of acceleration, all those kind of things. Would you be also able to post questions in the course Canvas site for the first week at least, whenever the course site is? Yeah, absolutely. That's the plan. Before the first day, there will be posted questions, and we're going to really start fresh and new. So you'll come ready by studying the chapter, and then all those assigned questions and problems assigned. But remember, there will be no shame, there will be no penalty of not able to solve 1 or 2 problems, which is totally fine. But of course, to get the most benefit, it's always recommended to solve all these problems assigned to you. And of course, the problems we're going to go along and then solve in live session together. So that's the plan. You're welcome. Absolutely, Julia. Go for it. If you're really passionate about USA physics, I would say this: remake your passion for International Physics Olympiad. Right? Then you're going to not only make it into USA Physics Olympiad, but also you can ace and pass and then represent US at the International Physics Olympiads. So definitely. Wish I was able to teach that course as well, but I think this is the course I will be teaching this semester. Another question: in case a class is missed on a particular Sunday, will the lecture be recorded? Yes, lectures will be recorded. Did we record the session? Let me see if the session was recorded. I need to really make sure that the sessions are. Yes, the session is also being recorded, and the sessions will be typically recorded. They will be posted. Also, some materials will be posted that I find very important for AP Physics C, and it will be available as a material in the modules, related modules, and you can definitely access those, watch them later on, and then if you have any questions, you can always go and reach out to me or post questions through Canvas. Thank you very much, beautiful people. So we're going to really be together, hopefully, if you decide to get this course. And for any further questions, you know what to do. So this is AP Physics C Mechanics, which is best for AP Physics C test exam, but also it's really good for AP Physics 1. If you're considering taking both, you're welcome to do so. All right, have a wonderful and take care.